Hello everyone, welcome to this kickoff video of your very first assignment in this course. In this video I want to at first give you some general information about the assignment, then I will show you the assignment description, I will show you how to compile, run and test your code, and at the end of the video I just want to give you a few hints that might be helpful when working with structs. But at first, let's take a look at some general information of assignment 1. In assignment 1, you will have to implement a simulator for a Spritzerstand. If you don't know what a Spritzerstand is, that's not a problem. Just think of it as a small store, a selling of drinks, where customers can order drinks or return deposit glasses, so Pfand in German. Those two are the main interactions with the simulator, and for each interaction you're supposed to print a brief summary. This will be explained in more detail later on when we take a look at the assignment description. The deadline for A1 is the 29th of October at 6 p.m. So depending on the release of this video, there are roughly 2 weeks left. A1 is worth 12 points. How can you get those points? 70% of those points are related to functionality. We use test cases to test your solution. A test case is pretty much just an execution of your program with a given input. We check the output of that execution and compare it to a reference output. If those two outputs match exactly, a test case is considered passed. And if there are differences, even slight differences, a test case is considered failed. We have public and private test cases to test your solution. Public test cases you can run yourselves locally on your PC, and for those you do know the inputs and outputs. Whereas for private test cases you do not know the inputs nor the outputs, you only know how many private test cases you pass, and if you fail, how close you are to passing them. Private test cases you cannot run on your own. Private test cases are triggered automatically in GitLab whenever you push to your GitLab repository. The other 30% of the points are related to code quality, so that is coding guidelines and the style guide. This, for example, includes guidelines that help you structure your code. For example, you should create several functions, give those functions meaningful names. You will have to create variables, give those variables meaningful names. Each function should have at most 80 lines. No line of code can be longer than 120 characters, and so on. Now, the functionality and the code quality make up 100% of the points, but you can get deductions. For example, the violation of specifications. There are general specifications that must be followed for every assignment. This is, for example, the usage of goto or the usage of exit. But there are assignment-specific specifications as well, which are always mentioned in the assignment descriptions. There are a few more deductions that you can get during the assignment interviews, but this does not happen too often. If you have solved the program yourself, or if you've written the code for your solution yourself, you know how your implementation works and what it does, then the assignment interview will not be a problem. So do not worry about those deductions too much. That being said, the assessment of assignments is described in a lot more detail on our course website in Notion, so make sure to check that out. And grading pattern in general, so the 70% functionality, 30% code quality, plus the deductions, this is always the same for all assignments. Now you will get access to a Git repository for each assignment, and you maybe already have access to that repository for A1, or you will get access very soon. Either way, you will get a notification via email. And in this repository, you will find the assignment description, which includes information about the assignment specific specifications, grading and how to submit your solution. You'll also find the public test cases that you can run yourselves locally. using a makefile, which I will show you later on. And it is important that you implement your code in your own repository. Each student will get their own repository, and this is where you should implement the code, commit and push. Do not write code in the upstream repository. You cannot submit anything there. So make sure you are working in your own repository and you commit and push to your repository on GitLab, because the last commit before the deadline is what we will grade. Now we recommend committing and pushing regularly, at least once well ahead of the deadline, just to check if committing and pushing works for you. Because if you only realize a few minutes before the deadline that you cannot push to your repository, we probably will not be able to help you and you will miss the deadline. So definitely commit from time to time and push. First, because of that reason, just to detect any technical difficulties early on. And second, whenever you push to your GitLab repository, the test system will automatically trigger and test your code against the private test cases. And you will, it will tell you how many private test cases you pass. Okay, so now let's take a look at such student repository together. Okay, so I have now opened a student repository in GitLab. In this case, this is our tutor test repository that we use for testing the reference solution, but it looks exactly the same as your student repository, with one exception, that your student repository will of course not ship with the reference solution. At first, let's pay attention to the name of the repository. Here it says ISP winter semester 25-A1-tutor test in this case, but your repository will have a 3-digit number here. This number is the identifier of your repository, and whenever you ask us to look at your code because there is a bug or just something that you cannot fix on your own, make sure to include this repository number, because then we know where to check and who you are and so on. Alright, let's check the files that you will find in your repository. The tests folder, test.toml, and the test runner. You don't really know what those files are, just know that they are used for running the public test cases. A1.c, you will need to create this file on your own, and this is where you will put your implementation source code. README is the assignment description that GitLab has already opened by default, and a makefile is used to compile, run, and test your code. I will show you this later on. Alright, let's check the assignment description. Introduction we have already covered. For each assignment there are some learning goals that need to be fulfilled in order to not get a deduction, so make sure you fulfill each of those. Some of those learning goals, in this case at least, you will fulfill by default, because without those you cannot even solve this assignment. So for example, variables, you will have to create some variables. Variables have data types. Make sure to create functions. Do not write all of the code in the main function. You're supposed to split the source code across multiple functions, give those functions meaningful names. This is really important, you really need to do this. Conditional statements, you need this anyway, without it you cannot solve the assignment, and loops as well. Without loops you will not be able to solve this assignment. The structs, you do not necessarily need to solve the assignment, but still create a struct, because this is one of the learning goals, and in the assignment specific specifications you're asked to create 2 structs. So the interaction of ordering drinks should be represented as a struct, and the interaction of returning deposit glasses should be represented as another struct. Later on in the assignment description we will get more details how those structs should look like. But be sure to really create 2 structs and use them in your code, because if you fail to do so you will get a deduction of up to 25%. Grading we have already covered. A1 is worth 12 points. Check out those links if you want to see how your assignments are graded in detail and how you can get a grade for the practicals. Create the file a1.c, this will be your submission, and you submit by committing and pushing to your GitLab repository before the deadline. There are weekly exercises associated with each assignment, and weekly exercises are supposed to help you. They're basically just a programming exercises, just some practice for you to get used to the learning goals or just to programming in general. And make sure to solve those, at least 50% of the weekly exercises, because if you do not do that, you can get a deduction of up to 25% on the points of A1. Assignment description, we already noticed there are 2 interactions, one for ordering drinks, one for returning deposit glasses. There are some general notes, make sure to read that. Okay, now let's start with some inputs and outputs of the program. So the first message that is printed when running the program is this welcome message here. And whenever you see something in the assignment description that says print this kind of text, I recommend copying this code and pasting it into your source file. Do not just type those output messages, because if you make a typo, especially a typo in a text that is only printed in a private test case, it is really hard to find such mistakes. So I recommend always copy paste output messages into your source file. Now the first prompt is regarding the interaction type. So the program asks the user what they want to do. They can either return glasses or order something. The third option is to quit the simulator. And you select an option by just typing the number next to that option. Whenever you see this symbol here, it means that the program should wait for input from the user. The user can now input 1, 2, or 3 to choose whatever interaction they want. As you can see here, only the values 1, 2, or 3 are considered valid inputs. If the user enters a value other than that, this is considered invalid input. And whenever you receive invalid input, make sure to print an error message. There's always an error message for invalid inputs. And then ask the question again and prompt the user again for some input. This is described here. And also in the general notes, make sure that you treat this error handling correctly. And now let's take a look at the first interaction, which is returning deposit glasses. Now remember, this interaction should be represented as a struct, and it basically means create a struct where you put everything related to returning deposit glasses in it. So create a member for all of the user inputs, for example. The user needs to input the number of glasses. This should be one member in the struct, and the glass size should be another member in the struct. You can put a couple more members in the struct if you want. So if you find them useful, just go ahead. But those 2 members must be included within the struct. The program asks the user how many glasses should be returned and what size there are, because depending on the size, the deposit fee is different. Now here the valid inputs are 300 or 500, so there are no numbers next to those options. The valid inputs are the values directly, so 300 or 500. And at the end of the interaction, just print a brief summary where I just say this is how many glasses you have returned, this is the deposit fee, and this is how much money you will get back. That's pretty much it for the first interaction. Now for ordering drinks, this type of interaction should be represented as a different struct. Make sure you create 2 structs. Do not combine those interactions into one single struct. Make sure you create 2 structs. And again, put everything in the struct that you need. For example, the type of drink that is ordered, the glass size again, and the tip. So the first input that we need from the user is what drink to order. The user has 3 options here, and again the valid inputs are 1, 2, or 3. Now the glass size, this is important. This prompt looks exactly like the glass size input of the returning deposit glasses interactions. So now we already know that we have some piece of code in our program that can be used twice. So we have reusable code. And now think of it how you can create reusable code. Maybe this is related to one of the learning goals, but this is really important. Pay attention to that. And the last input is the tip. And that's already it. Just a summary again at the end of the interaction where you say, this is the drink that I have ordered, this is the size, this is the price of the drink, this is the deposit fee. Total without the tip is really just the price of the drink plus the deposit fee. There's no tip included yet. And then you calculate the tip based on this value. So please apply the tip on the sum of those 2 values and then print the total price that the customer should pay. And that's pretty much it already regarding the entire assignment. There are a few example outputs which you can take a look at if you want. And now I want to show you a live demo of the program. Okay, so I have now logged on to the virtual machine where I have already cloned the tutor test repository, and we now want to run this code. So what do we need to do to run source code? We need to compile it at first, and I will show you how to use the makefile to do so. So let's go ahead and open a terminal in this repository. Right click on the folder and click open terminal here in the context menu. And let's type make bin to compile the source code. And it has now compiled the source file into this A1 binary file. Do not get used to the makefile too much, because during the assignment interviews of A1, you will be asked to compile your source file manually. And how to compile the code without the makefile. We can actually use the makefile to see what command was executed for compilation. And this is this command right here. So clang, that's the name of the compiler, a bunch of arguments, and a1.c is what we wanted to compile. You do not need to know all of the arguments here, but at the bare minimum you need to know clang and the input file c1. So the shortest way of compiling a source file is by typing clang, so the name of the compiler, and the source file that we want to compile. This is just the information the compiler needs, because without this argument the compiler doesn't know what to compile. But I will still explain the other arguments very briefly, just so you kind of get an idea what they are used for. But during the assignment interviews, you do not need to know those, but it's still recommended that you kind of have an idea what they're doing. So this -o argument, it just tells the compiler how the output executable should be called. Here it says A1, that's why this A1 executable file is called that way, because we've specified it here. Those 3 arguments, WR, WExtra and pedantic, they're just related to warnings. With those 3 flags we just get more warnings, so we just enabled some warnings that we wouldn't have had without those flags. And this W here stands for warning. This WR has nothing to do with a war. So this is warning or warning extra and pedantic. Pedantic is actually related to the warnings regarding the C standard, but you don't need to know this. G flag is used so we can debug our program. Without this flag we are not able to debug. And this LM says that we want to link the math library, so we can include the math.h header and use some mathematical functions like square root, for example. And that's pretty much it already. So at the bare minimum, you need to know clang, name of the compiler, and the source file, what you want to compile. Make sure you know that during the assignment interviews of A1, because if you do not know this, you will get a deduction. Okay, so that's make bin. We can also type make run to compile and run the program. We now see that the program was compiled at first, and now we have executed it using this ./A1. A1 is the name of the binary that the compiler produced. Okay, now let's just see how the program behaves. What do we want to do? Let's say we want to order something at first. What do we want to order? Fizzy water, 500 milliliters glass. How much do we want to tip? 10%. So a 500 milliliter glass of fizzy water is €1 just the drink, €2 the deposit fee. That means the total before the tip is €3, and we give a tip of 10%. That means the total will be €330. Okay. Next interaction. Let's say we want to return something this time. How many glasses do we want to return? Type 2 and confirm with enter. What glass size? 300 this time. We've now returned 2 glasses at €150 each. That means we'll get €3 back. Okay, now I'll show you the quit command 2. Just type in 3 and enter, and we can see that the program terminated. So that's pretty much it already. Now I also want to show you how you can run the public test cases. And to run the public test cases, we use the makefile again, and we just say make test. Now this will take a few seconds. We can already see some output, starting tests, finish, test case 1, and this just prints a brief summary of each test case and how well we did. Now in this case, the reference solution passes all 5 public test cases. We see output diff 100%. That means that the output our program produced matches exactly the reference output, so the output that we expect. Okay, if we now want a bit more details of the test cases, make test also produces this test report.html. We can go ahead and open this, and this will print more information for each test case, where we can see the reference output, so what is expected, compared with my output, so what my program or the reference solution really output in this case. And if there are some differences here, it will be marked, or it will be highlighted with green and red, I believe. But in this case, there is no differences, so there's nothing highlighted. But make sure to check out this test report file if there are some test cases that you fail. You can also toggle invisible characters here. So as you can see, usually all white spaces are marked here with a dot, or the newland character is also highlighted. If you want to get rid of those, you can use this toggle invisible characters button. Now, as I've just shown you how to run and inspect the public test cases, I also want to show you how you can inspect the private test cases. And for that, I have switched back to GitLab and opened the repository. And if we now want to take a look at the private test cases, we'll check out this side menu that we see on the left-hand side here. We go to build and go to jobs. And for each push commit, this test system pipeline will trigger automatically and run the private test cases, including the public test cases, on your submission. And now if you want to inspect the private test cases and how many test cases in general you pass, just click on this on one of the jobs here. Usually you want to click on the most recent job, because this is the most up-to-date state of your code. Just go ahead and click the most recent job. I've already done that. And what you see now is output similar to what we've seen when we ran the public test cases earlier locally, with one exception that we also see output of the private test cases. So if you recall, we have test cases 1 to 5 are public test cases, and test cases 6 to 10 in this case for assignment 1 we have 10 test cases in total, 5 public, 5 private, and we see that we are actually failing the last test case. So even though our solution passed all 5 public test cases, there was some kind of functionality that was not covered in the public test cases, but that is tested in the private test cases. So this is why it's really important that you write your own tests. The public test cases do not cover 100% functionality of your code. It's really important that you write your own tests, because the private test cases most likely, or I can say definitely, test something that is not part of the public test cases. Okay, but this is all the output we get. There is no test report for the private test cases, so there's no side-by-side output comparison. We only know that we miss the last test case, the test case 10, by only 5% if, so we are really close to passing the test case, but maybe there's just a small calculation error or something like that. Now you can still download a test report. Over here on the right hand side you see job artifacts, where you can download this test report HTML file again, but this will only give you information on the public test cases. For the private test cases there is no further detail apart from that. Now I recommend always checking out the output of this test system pipeline for 2 reasons. First reason, of course, you want to know how many private test cases you pass, and this pipeline also outputs warnings that you do not see when you run the public test cases. So in this output you will also see if you have used exit, for example. So definitely make sure to always check out what the pipeline says. We are almost done with this kickoff video, but at the beginning I mentioned that I wanted to give you some hints on how to deal with structs, and this is what we are going to take a look at right now. So I've created this dummy program just for demonstration purposes, where I've created 2 structs. So we have the employee struct, which has 2 members, ID and age, and another struct, which is the client, which just has some number as a member. This example here does not really make too much sense. It's really just some dummy project which I want to use for demonstration purposes. So those are 2 structs. We have now declared 2 structs, and your assignment solution will look similar to this. So we definitely want to see 2 declarations of structs. One struct for the ordering of drinks, and another struct, a different struct, for the returning of deposit classes. Now, with just those 2 lines, we have not really used the struct in our program yet. The only thing we've said is that we can have those structs if we want to. We've basically more or less just declared 2 data types. If we now really want to create actual structs, we want to instantiate this struct, we create some variables with this struct as data type. So just as you are used to declaring variables with a different data type, for example, integer or float, just use the struct as the data type here. And this is how you can initialize a struct directly when creating the struct. So here I say that John has ID 1 and age 35. And Eve has ID 0, and we do not set an age yet because we want to do this later on in the function, which I will explain in a second. And here's also this client variable, which doesn't really make sense. There is no use to this variable in this program. I just wanted to show you that you can also instantiate a struct and directly specify the name of the member here. Notice here we have not really specified the name of the members, but here we did. Here we said that number is 1147. Okay. So if does not have an age set, so we want to use this set age function here, which just takes two parameters, some employee and an age, and the only thing it does is set age as a parameter to the age member of the struct. That's all it does, and then it prints age updated. Okay, we call this function, and then we just print the age of Eve. Now, if we compile and run this code, I guess we will see that Eve is 24 years old, because this is what we set here in this function. Now let's try that. Let's open a terminal. And we need to compile our code manually now, because we have no makefile. And how do we compile code manually? We type the name of the compiler. Now we say what file we want to compile. In this case, it's called version1.c, and output file, let's just say bin. Okay, compilation succeeded. And now let's run the code. And it says Eve is 0 years old. Even though the function was definitely called, because we see this print here, but somehow the member of this struct was not updated. And why this is the case, you do not really need to fully understand at the moment, because we do not know what pointers are. But just so you know that the employee that is passed here as a parameter is actually a copy of this struct. So the struct we're updating here is not the struct that we have declared in the main function. It's just a copy. And this update here only has an effect locally in this function. The struct that we have declared in the main function is actually not modified by this at all. So whenever you want to update members of a struct in a function, be very careful. But there is a solution how we can solve this for now without using pointers. And we just do a small trick where we actually return the struct again. Now, if we compare those two functions, we see that setAge is no longer a void. setAge now returns an employee, and it just returns the employee that was given to it as a parameter. And when we call this function, we now catch it and just assign it to the struct that we wanted to update. And this basically just overrides the struct that we have declared in the main function with the struct that is updated and returned in this setAge function. Now we can open another terminal. This time we compile version 2.c. We call it binary again, and let's call it. And this time it really does what we expected. It now says age updated, so the function was called, and Eve is now really 24 years old, because the update that we made in this function really has overwritten the struct that we declared in the main function. I'm not saying that you have to use this in your assignment. There are probably ways where you can do this without passing structs to functions and modifying them. But if you want to do something like this, modifying a struct in a function without passing the struct as a pointer, this is how you can do it. This is just a hint I wanted to give you. Maybe you find this helpful when solving the assignment. Okay, back to the slides one last time, and I'm going to skip a few slides now, because we have already covered that. I've put the most important commands on the slides, so if you come back later again during or while you're working on the assignment, you will find those commands on the slides and you don't need to watch the video again. So running and testing locally, we have already covered that. You can use the makefile, but still you need to be able to compile your code manually during the assignment interviews. Make run compiles your code and runs it afterwards. Here you can also see the command used for compilation again. Make test we have covered. This runs the public test cases on your solution, and it tells you how many public test cases you pass. How to inspect the private test cases we have also seen. Use the test system pipeline on GitLab for that. Okay, and now we have really reached the end of this kickoff video. If you have any questions, make sure to ask us on Discord. There's a separate A1 channel for questions. So if you need anything, just let us know. There's also a dedicated question hour for A1, which will be held on the 27th. But this is only like a couple of days before the deadline. So make sure that you have already started by that time. Otherwise, you probably will not be able to ask meaningful questions that really help you. Okay, so if there are any changes to the assignment description or there are some mistakes in the test cases, all of that and a lot more is always announced on Discord, so make sure to check Discord regularly. As always, start early with the assignment, do not underestimate it. Maybe it looks quite easy, but especially for beginners, it might not be too easy. It might actually be very challenging and time consuming. And yeah, I have to mention the next point. Do not copy code of your colleagues. Do not show your code to someone else. Do not copy code of the internet. Do not use AI to generate code. Yeah, I guess you already know this, but every year there are a lot of students who fail this course because they have copied the code from someone. So yeah, really try to solve the assignment yourself. If you do so, you will learn a lot, and also the assignment interviews will be a lot easier for you. Okay, so I have mentioned everything I wanted to mention. I wish you all the best for A1, and we will see each other again in the next kickoff video. Goodbye everyone.